Okay, well, welcome to the last session of the course. It would be nice for me to go home a little earlier on Wednesdays from now on. So I'm kind of excited for this, but also excited that we actually did 12 hours of this course. Okay, so today we're going to be doing a case-based learning in medical AI, and I'm going to do a little bit of a wrap up. Maybe the other way around, I'll maybe give you an overview of what we've talked about in the course. You probably already know me because you've heard me blabber so many times. But my name is Ehsan, and I am an MD PhD student. I'm the current president of the AI and Medicine Student Society, and I've kind of moved on to the national nonprofit that we've recently incorporated called the AI and Medical Systems Society. Very intuitive and I guess very creative of us. So I'm one of the co-directors and co-founders of that. So please expect more things coming your way from the national nonprofit as well pretty soon. Okay, with that being said, I will do a disclaimer at some point, but I asked Bing AI to give me an objective for this session, and I specifically told it it's a 1-hour lecture. So these are what it came up with. So you're supposed to understand the basic concepts and terminology of artificial intelligence and its applications in healthcare. That's a course in and of itself. To learn how to critically appraise a research paper in medical AI using a checklist of criteria. And I love the checklist of criteria: objectives, methods, results, discussion, and references. Those are specific parts of a paper, not criteria, but okay. To identify the strengths and limitations of medical AI studies and their implications for clinical practice and research. Great objective. Again, not sure if I can do this in an hour. To compare and contrast different types of medical AI problems, such as image classification, natural language processing, decision support, and prediction. And to explore some current and emerging trends and challenges in medical AI, such as ethics, privacy, bias, regulation, and validation. Yeah, I think I need about 36 hours to go through all of these objectives. So I made this a little bit more realistic. So I'm going to review the basic concepts that you've already learned. I'm going to tell you a little bit about critically appraising a research paper in medical AI. And we're going to do this checklist of criteria, but not the checklist of criteria that Bing suggested. And we are going to identify some broad strengths and limitations of medical AI. With that being said, I'll do some declaration disclaimers. I don't have any current involvement in developing AI tools to be used in healthcare, but this is up and coming, so I might have other of those to report at some point. I am involved in leading the AI Medicine Society and the AI Medical Systems Society, no other conflict of interest. And I have used ChatGPT and Bing AI in preparing the material for this lecture. So I've used AI to tell you about AI. Okay, so as I mentioned, we're going to do a brief review of basic AI. You probably are experts at this by now. We're going to review some of medical AI applications. We'll do the case-based learning, and then I have like a couple slides on what I think the future of medical AI could look like. Okay, so review of basic AI. I'm going to essentially borrow from all of the slides you've been told. So Hollis told you about how AI works. So you have the training, performance, and evaluation steps. I have a bunch of pictures of dogs and cats. I give it to a deep neural net here. I get some sort of an accuracy, 85%, let's say. That's pretty good. That's the performance right now with the training. So we keep going through these steps. We have validation steps and all that stuff as well. Amira told you about some of those too. And then at some point we do an evaluation with some brand new images. We give it to the same neural net that we have used before, and you get a 75% accuracy. Usually this accuracy number is going to be lower than this just because your algorithm is going to learn more about the training set that it's going to know about the test set you're going to use it for afterwards. Okay, so what if I wanted to build an AI algorithm? It's actually easier than you might think. So the first step to do this is to learn Python. Afia told you a little bit about this and some of the following libraries. So NumPy is one of the most important ones probably to learn. Pandas, Matplotlib and Seaborn to do any sort of graphing that you want to do with Python, and then Keras and PyTorch are two of the mostly used, I guess, libraries. There's TensorFlow and there's other ones as well. But I can also rep Ames here. We're going to have a community project coming up pretty soon. So you can actually learn on the job. So you can join the community project and essentially we're going to have workshops to start from scratch. So if you've never done coding, that probably would work for you. So if you are interested in this, either let us know on Slack or on the survey link that I'm actually going to put up at the end of today's lecture. There is a place where you can actually say that you're interested in hearing about it. Okay, and then machine learning models. So Gulnaz told you about some of these. Decision trees are one of the basic machine learning models. Essentially, we use this every day. You kind of look at something and you decide, okay, is it this or is it that? And then kind of go through the whole process. K-nearest neighbor is another machine learning model where you essentially choose a K, I guess an arbitrary K, and then you decide which class that new data point belongs to. Linear regression, very much used at this point. I don't know if it's considered even machine learning because the definitions evolve. Logistic regression is a little bit more sigmoidal and exponential, and I guess a little bit more advanced than linear regression. Deep neural nets, this is probably what most people think of when they think of AI, and convolutional neural networks that are mostly used for images and image classification and that sort of stuff. Jeanne told you a little bit about machine learning types. So supervised, non-supervised learning. There's also reinforcement learning that's not on this slide. And then some of the examples of these, again, we talked about this before. Classification problems, regression problems are under supervised, and then clustering problems are under unsupervised learning. Okay, so where in medicine can AI actually help? And I know I'm going through these slides really fast, but it's because I've essentially borrowed them from before, so you kind of seen these already. But where in medicine can AI be used, or where in healthcare essentially can it be used? Well, I can argue everywhere, but more specifically, it can be used in prevention, it can be used in research, it can be used in diagnosis of certain diseases, and it can also be used in treatment. And I actually really like this quote that I grabbed from this paper, where it says, to be a this is actually very interesting because it's kind of true, but not a lot of people think about it that way. But to be a competent doctor, an AI system does not, and replace the doctor with a clinician or healthcare professional or whatever. But to be a competent doctor, an AI system does not have to be the best doctor in the world. It has to be better than only the worst graduating student in your class. So think about a medical school class. There's 170, 160 people in that class. If AI can do better than the worst graduating student, it's a pretty good doctor, isn't it? If AI is better than your average student, it's better than 50% of all doctors. Moreover, as seen from the references above, where in the paper there are some references, there are already systems that can perform several tasks better than some of the best. So AI is on track to achieve this. We'll see what happens with the moratorium on AI systems. I don't think anyone's going to care what Elon Musk and Yuval Harari told people, but we'll see if that's going to result in any sort of stagnation in AI. But the way this is going, we're probably going to get to autodocs or something in I don't know how many years, but we'll see. Okay, and then Amir Reza told you a little bit about this. I don't know why my slide is cut off there, but where do I start if I want to build a useful AI in healthcare or in medicine? And this is very important because there's a lot of people who are working on AI systems or AI algorithms where they don't ask the actual, the correct questions. So essentially, I think one of the most important things for everyone in this course and everyone watching the recording afterwards as well is to ask yourself, first of all, are you the clinician who's going to be using this, or are you the patient who's going to be affected by this, or are you the developer who's going to develop this? So if you're the clinician and you're the patient, look around you. What are some gaps in the system? What are some things AI can help with? And if you're a developer, please go talk to the people who are working with these things. Because there's a lot of people who are like, oh, I think this is a problem. And they build something. And 2 years down the road, once it's done, they show it to a clinician. They're like, oh, we don't have that problem. So yeah, you just wasted your 2 years. And so it's actually important to ask the important questions. So you need to understand the problem. What exactly is the gap you're trying to address? You need to prepare for that. So what do you need for that? You need data. You need to, again, talk to people who actually know what's going on the ground. You need a process, and you need to make it usable. You analyze and tell a story based on whatever you've learned. And then you share it. You get different views. So if you've talked to a clinician and built a model, you take it to another clinician, get them to use it, and get another perspective on that. And then once you know all of that, let's solve the problem. Let's actually implement it. Once you have to do this and you go through the regulatory steps, I wish you luck. It's not that easy. Okay. And then again, Amin Riza told you a little bit about this. So the sources of medical data, there's a ton of places where you can get medical data. You can get it from electronic medical records. Alberta now has a provincial medical record system, which is mostly connected. We have a lot of medical record information in there, not easily accessible for a lot of folks who are doing research, but at some point I'm hoping that's going to change. We have a lot of medical images and videos. You can get X-rays, MRIs, CT scans, and a bunch of videos of, for example, a patient walking. You can do gait analysis and that sort of stuff. Medical signals come in handy a lot. And again, genetics and omics, we've talked about this in the course as well. Genomics, proteomics, metabolomics, radiomics, whatever people want to put omics in front of. There's a lot of data up and coming from this as well. And then Nidhi told you a little bit about privacy and differential privacy. And essentially one of the major things at the end was, in most data sets, you could actually do differential privacy to help. And it's actually better than anonymization mostly. In terms of de-identification and privacy, but in healthcare scenarios, you might not be able to use differential privacy. Why? For example, dosing is an example. Dosing was an example that she gave. When you're using it as prediction or inference, even a small amount of perturbation can actually result in deadly consequences. And data sharing is really important in research. In health research, you need to be able to share your data with someone else. So how do you do that? Anonymization might not be the best way to do it. And essentially one of the things she talked about was there's a project they're working with AHS where they're trying to identify the privacy risk of sharing a certain data set. And looking at different ML models, different models have different susceptibilities to attacks. So you choose the best model that can give you the most anonymization, I guess. And if you can share only a certain portion of the data without compromising the research project. Okay. And then real quick, I'm going to do another review of applications of AI. We're at 6:16. Okay, we're doing good. So Dr. Richard told you about infectious disease public health. So some of the stuff that he was talking about was actually used during COVID. So looking at tracking outbreaks, predicting levels of infections, modeling efficacy of certain interventions, and estimating total morbidity from limited surveillance data. Shane told you about neuro stuff, so prediction in coma, medication overuse in migraine patients, whether you treat or not treat a certain stroke, extracting vocal features in Parkinson's, looking at battery life and side effects of deep brain stimulation, assessment of neurosurgical skills, which was actually the funniest of all. I think the result of that AI algorithm was, oh, neurosurgeons with more experience are better than second-year residents. Well, I don't know if I'm surprised. And real-time modeling of tissue deformation when they're doing neurosurgery. And then cardiology, Michael told you a little bit about this. Detection of atrial fibrillation, looking at now analyzing ECGs, asymptomatic diagnostic, and also prediction of any sort of readmission patients might have. And then during the same lecture, you also learned a little bit about radiology and pathology, AI is used in pathology detection, image classification, segmentation of tumors, any sort of prognostication, feature mining, data biobanking, workflow optimization, and logistical augmentation. And then in omics and oncology, Bahare told you about this, prediction of therapeutic effectivity of certain cancer drugs, prediction of survival of patients with a certain cancer, and predicting consequence of a specific genetic mutation, which is actually used a lot in research right now. And then Amira told you a little bit about primary care and how AI is used there. Risk stratification is one of those, remote monitoring, and up and coming kind of clinical decision support. There's actually a clinic down in the US that they're using this clinical decision support. They've published it as well. It's pretty neat. They use it for a lot of genetic disorders, but it can actually be adapted and be used in a lot of, I guess, primary care clinics of the future. And there are other domains of medicine. This is certainly not the end all be all. There's emergency medicine, there's anesthesiology, there's intensive care, pediatrics, rural and remote health. And then there's a bunch of other things in healthcare. There's nursing, dentistry, and all that sort of stuff as well. Okay, now, I think we did really good for timing. I know I rushed through all of those slides, but the main point was to get here. Okay. So when you look at medical AI literature, this is a bit of a general approach to a research paper. Some of you or most of you are grad students here or have done research before, so you probably already know this. But just to do an overview of this, so depending on what exactly you want out of a paper, you look at it differently. So we rarely, at least I rarely read a paper as a newspaper. I essentially don't go through abstract introduction, methods, results, discussion, and limitations or conclusions. Depending on what I want from that paper, I go to that specific section. So if I want to figure out what results they are showing in that paper, I first start with results. I don't need to read their introduction. And then once I do that, I want to see, okay, how does this result actually go within the current literature? So you go to their discussion, they're probably going to tell you a little bit about that. And you're probably not going to need the introduction at that point because they've kind of told you a little bit about what their results mean in the context of the current literature anyways. If I, for example, I do genetics research, so let's say I want to see what antibodies they've used for a certain staining, then I go to their methods section first, and I want to figure out where they got their antibodies from, what antibody they used, that sort of stuff. In an AI paper, you want to see what models they've used, so you go to the methods section for that. And then rarely you would start from the introduction and just to go through it. Usually when you're reviewing a paper, that's what you are going to do. You're going to read through their introduction, go through their methods and results and that sort of stuff. Now, a sample generic checklist for to look at an AI paper or a medical AI paper. And I guess, again, like this can be implemented in a lot of different disciplines, is first of all, the question you ask is this the right problem framing? Are they actually solving something that's relevant, that's useful? Have they used the right data set for what sort of problem they're looking at? What's their data preparation step? What exactly have they done on the data before they do any sort of processing on it? Is this the right design? Is the model they've used the best model they could have used for this? Have they gone through the right training steps? And is it the right operational readiness? Like, is this actually ready to be used and implemented? And so these are very general and generic questions, right? We're going to go through some of the checklists that I've actually found. There's surprisingly a lot of, well, I shouldn't say a lot, but a few checklists that people use to look at medical AI papers. So, for example, Consort AI is a checklist that's been adapted to be used in RCTs or randomized controlled trials using AI. Consort stands for Consolidated Standards of Reporting Trials. It's a checklist that's used in reviewing randomized controlled trials. But like I said, it's been adapted to be used in AI. Spirit AI is a checklist that's used for interventions in using AI. And this is, again, an adapted checklist as well. So it stands for standard protocol items. recommendations for interventional trials. And then MI claim is, this is like more of a clinical artificial intelligence modeling checklist, but the good thing about this specific checklist is that it's minimum information. So they have this like 10, actually, no, sorry, the MI claim is not the 10 one, but they essentially have these short checklist that you go through and you wanna figure out if this paper is suitable or not. Make 10 is the one I was talking about. It's a brief checklist, but this is specifically built for medical imaging. But it's only 10 criteria, so like must have 10 criteria essentially for medical AI papers. And then the one that I'm going to focus a little bit more on today is IJ-MEDI, which is the Journal of Medical Informatics. They have a checklist for self-assessment and also assessment of medical AI papers from reviewers as well. So some of the other questions that could be asked, this is, I grabbed this from a paper by these two individuals. Bertalan Meshko is a medical AI specialist in Hungary, I think. I might be mistaken on that. But he does really good, he used to do a lot of YouTube videos. At this point, it's a lot of newsletters, and also he does a lot of keynote speeches and stuff like that around the world. Some of it is really expensive. They're actually offering an AI in med course, and I forgot how much exactly it is, but it is pretty costly. And I don't know what exactly they're teaching in there, but there are some very free, there's some free resources on there. So if you're interested, you can search them up. But some of the questions, for example, in their paper, they want people to ask is, what aspect of existing clinical practice does the system reinforce, right? So it goes back to the right, like finding the right problem. And then data sizes, are the sizes of their training, validation, and test sets justified? And then essentially, how can we be sure the training data matches what we expect to see in real life? So if you're, I don't know, you've trained your model on cats and dog pictures that don't even exist, and then you give it real life cat and dog pictures, how is that relevant to what they trained it on, right? How can we be confident of the quality of the labels the system is trained on? So the ground truth, did you give this to a medical AI, a medical expert who actually knows what they're looking at? Or did you give it to, for example, a trainee who is very new to whatever you're trying to label as? And then was the AI algorithm trained using a standard of reference that's widely acceptable in that specific field? So if it's in radiology, they have their own standards of reference. If it's in pathology, they have their own standard of reference. So you need to go with those. And then was the manner in which the AI algorithm makes decisions demonstrated? Explainability. This is an important thing that's being talked a lot very recently as well, is can you actually explain what the AI algorithm has done to get to whatever result it's showing you? And then were the results compared with experts in the field? Like, how does it do when it's compared with the experts? And again, going back to that comment that paper made, you don't need to have a system that does better than every expert it encounters. As long as it can do pretty good, you can use it in certain settings. Let's say in a remote setting where they don't have experts, you can at least have something that can be used, right? Like rather than nothing at all. And is the system applied to the same diagnostic context that it was trained on? Again, it goes back to how the training data compares to whatever it's going to be tested on. And is the AI algorithm publicly available? This is an important thing as well. It goes, if they're like, oh, we did this in-house system, and you're not going to have any sort of access to that in-house system that they're talking about, how is that, like, how are you going to use that? How are you going to trust the results of that without being able to reproduce some of the stuff that they've talked about? So I'm not going to go through this checklist, but this is the Make 10 checklist that I was just talking about. And it essentially gives you the article section and the description. But there are these like 10 checklist items that it just asks you to review in a certain paper. I want us to do a little bit more than this today. So that's why I'm going to go to this. And I know this is a lot. So again, I'm not going to go through this whole checklist. And you have these on the slides that I'm going to share afterwards, so you can go back to the slides and just review these. But like I said, this is the International Journal of Medical Informatics. They have this paper in the journal that's essentially the checklist for them to publish any sort of medical AI paper. And the questions they ask are categorized into a specific category. So there's problem understanding, there's data understanding, and there's a bunch in the next slides as well. And then you get a score. Each paper essentially gets a score from each one of these. So if it's a bold question, then that's a 2-point question. If it's not a bold question, that's a 1-point question. So like in here, for example, you can get a 2, another 2, that's 4, 5, 7, 9, and 10. You can get a 10 in problem understanding, and essentially you get a score out of 10. The paper gets a score out of 10 from those. Same thing with data understanding, and then a bunch of other categories. It has its data preparation, modeling, validation, and this is the rest of validation. Same thing, the rest of validation, and then deployment, and that's it. So there's 30 questions, but obviously the score is not out of 30. So each one of these have different scores. And what I want us to do is I have chosen a bunch of questions from each one of these for 2 separate papers. If we have time, we can do another paper. I don't think we will have time for a 3rd paper, but we'll see. So what I want us to do is to practice. So I see you 3 can practice together. I'll get you 3 to come closer to each other. And then the rest of you, I think you can kind of in groups of 3 or 2. Does that work? Okay. So I've made sure I have a bunch of ways for you to access this. So the link is there. There's a QR code and the name of the paper is there. I've also chosen an open access paper. So those of you online, if you're not on the U of A network, you can still find this paper. And what I'm going to do actually is maybe I will put the link to the paper on Zoom too. Oh, actually, Amir Reza is on top of it. Okay, he's already done this. Okay, those on Zoom, you already have the link from there. And yeah, this is the enabling fully automated insulin delivery. Okay, so maybe I could have included this in here. That's fine. Okay, once people in person have opened the paper, hey, folks, don't just sit by yourselves. Come on, be a little bit more friendly. Mingle. And essentially what I want you to do is we're not going to go through these papers in full, but what I want you to do is skim through specifically their results and methods, because I think that's the most most important stuff we're going to focus on. So skim through their methods and results, figure out what they've not, I shouldn't say exactly, but figure out what they've done generally, and then I have a bunch of questions for us to answer when we've done that. Okay. Those of you in person can disregard this. But those of you on Zoom, I think we might want to put you in breakout rooms. And what I'll do is I will actually share a document with you. So you have the links. Sorry, not the links, the questions. That hopefully does work. And then Amir, is that, could we put people in groups of maybe 5? And maybe what I'll do is actually, I will just go to the slide with the questions. You can kind of look for them as well, and then we can discuss it. I'm thinking 10 minutes, but we can reevaluate that in just a bit. And if by any chance you're done a little bit earlier than 10 minutes, just let me know and we can keep going. Okay, I think we closed all the Zoom breakout rooms. Sounds like it. Okay, let's bring back the group. I hope you had time to kind of go through the paper. What I'm going to do is actually, okay, let's just do the discussion. Okay, so first of all, I'm going to do what Amira did last session. What do we feel about the paper? How do we feel about it? Small sample size. Okay, so that's one thing. That's actually a very good point. Anything else?
Like what they actually did wasn't real life. They took photos and then said, okay, what would be your close photo? This how much it would give you, and how different was it from what you did?
So not really, for those of you who didn't hear that, not really real life stuff that they've done. So how useful is this, and how much of this training data can actually, or essentially how much the training data can be applied the same way that the test data in real life would be applied, right? But it's a pretty interesting problem they're trying to solve, right? This is something that a lot of people with diabetes are dealing with. You have to essentially do meal detection and size estimation and carb counting and that sort of stuff. It becomes frustrating. So it's pretty useful thing in that. But did they go about it the right way? I guess that's the whole point of doing some of these checklists and trying to look at the data. But again, we don't have time to go through the whole 30 question of the IJ Medi checklist. So I put in the 4 questions that I thought would be good to kind of go through for this specific paper, and I'm sure you've talked about these. So I guess we'll get started in these. And people online, I'm monitoring the chat, so if you have anything to answer, I'm happy to read them out too. So the first question I want to ask us is the study population described, especially in terms of inclusion-exclusion criteria, and like, have they essentially done similar to what the examples are in here? Yes, okay. And okay, yeah, I see online as well. So where do they talk about this? In the table. We're talking about this table, right? So baseline characteristics of eligible participants. And again, yeah, very small sample size, 15. I'm sure you could find more people who would be interested in doing something like that. Well, I shouldn't say I'm sure. I'm in research. I know how hard it is to get people to do actually research studies. So I shouldn't be saying I'm sure, but I'm kind of feeling like 15 is a little bit of a is a little bit too low. But
They know that study design and parts, they have like a whole paragraph, like a whole section.
I think it's in the study design and their methods, right? Yeah, I think I saw it there. Carb model estimation.
But like, was it the first 15 people, like, how did they get those?
Well, I mean, that's what their diagram here was supposed to do that, right? But they just started from assessed for eligibility. It should have had something of like, we had this many patients, or we looked at this many charts, for example, and then we chose these based on the eligibility criteria, and then we had this many retention or whatever, and then we ended up with 15. But it just goes into, we assessed for eligibility in 15 people, and then we just chose and just put them in randomized groups.
At emergency room, people who are having problems, you get a really different answer than, I don't know, if you found 15 people at Whole Foods.
Very true. Exactly. So where you do your participant recruitment, is actually important. Did you post this on Kijiji and get people through there, or whatever people use nowadays, or Facebook Marketplace? I don't know. Do people use that for research? Okay, I see a point online as well. I also wonder how representative the study population is, as the vast majority of participants are Caucasian. Very, very good point. And I think that's actually one of the criteria that IJ Mehdi, excuse me, IJ Mehdi actually looks at. So I guess we can actually get to that question. So are the subject demographics described in terms of average age, age variability, gender breakdown, ethnic group, and socioeconomic status? Not to that detail, right? I think this is the table that I opened initially. This one right here. So yeah, they talk about the age, biological sex. So they don't talk about gender, I don't think. No. They talk about weight, ethnicity. And I mean, it's also an American study. So obviously their ethnicity is just, they just think the only ethnicities out there are apparently white, black, and American Indian somehow. But anyways, and then they also describe HbA, hemoglobin A1C, duration of diabetes in years, and CGM use. But yeah, so there is average age. There is the age variability. So they talk about the standard deviation. There isn't a gender breakdown, but there's a biological sex breakdown. They don't talk about main comorbidities, I don't think. The table does not have it. I don't remember seeing seeing it in the participants either. And then ethnic group, they talk about that at least, but again, not too detailed, and no mention of socioeconomic status, right? So, well, they probably don't get the full, I think this is a 2-point question. They probably don't get a full 2-point for this one. We'll probably give them a 1, as if we have a say on a paper that's already been published in Nature. Exactly, in Nature, no less. Okay, is the model task reported? What is the model task? It's in their methods again, right? I believe I found it at some point, but I can't find it. Yeah, so they used 2. There was multiple, where is it? I'm sure I saw it somewhere. Yeah, I might want to just do that. Is it multi-classification? Okay, there we go. Yeah, so exactly. So for meal detection, they've used binary classification. And yeah, I see online as well, same thing. For meal detection, they've used binary classification, and for carb estimation, they've used multi-class classification. And then they kind of go into details of what they've done for each one of those models. But yeah, so the model task is reported. So they get the score of that. And then the last question for this paper I have is the model output specified? Did you find this? I believe they said it somewhere. I think I found this when I first looked at the paper. Study outcomes. So essentially they're looking at meal insulin recommended by the robust artificial pancreas system for true positive meal detection, and the adjustments made to participants. I'm going to say these are their study outcomes. No, it doesn't say that. Did someone find their study outcomes? Where is it? Oh, and the study outcomes? Oh, outcomes. There we go. Yes, exactly. So the primary endpoint, the incremental area under the curve of glucose, and then percent of time with glucose sensor and target range between 70 and 180. Yeah, so they talk about their outcomes. So the model output is actually specified. Well, that was actually a study outcome, but I guess they're going to have the model output to get to the study outcome, because otherwise that wouldn't make sense. Okay, so okay, 6:56. I don't have time to do another paper, but I will share the link to this, and obviously you'll have the link on the slides, so you can go through this. This is also a pretty neat paper. They've done it in sepsis, which is actually an issue, a major issue in healthcare. So it's pretty nice to go through this. And those of you online, Amira's just posted the link to this as well. I won't go through these, but very quickly, I will just share a couple slides about the future of medical AI research. And I specifically put research in there just because for some of these things to get implemented, specifically in healthcare, it's going to take a bit of time. So I actually found this pretty good chart in a paper where they talked about progress, challenges, and opportunities for AI in healthcare. And then their progress part is essentially, they talk about some of the medical specialties that AI is very used nowadays. So obviously radiology and pathology are up there. In the deployment progress, they talk about prospective trials, FDA approvals, for example, and then CMS reimbursements. And in their challenges, they talk about some of the up and coming challenges, or I guess current challenges for implementing AI. So there is model trust. So you need to get your clinician and your patients to trust the model you're using. There are limitations in data. We talked about anonymization and that sort of stuff, plus study participants. The paper we looked at had 15 people in there. So that's a pretty, that's not a lot of data. In terms of accountability, you look at regulations and responsibilities of essentially people who are using these algorithms and people who are developing them. And then in fairness, you essentially want to use ethical, or you want to have ethical data usage. And then you want to keep in mind equity and bias. Not all of your training data set has to come from a certain ethnicity, for example. And then some of the opportunities in the future. So we talked a little bit about electronic health records. Alberta can actually be a future leader in this if hopefully AHS at some point decides to do something about this. They're getting there. I've heard good things recently, but and then like other non-image data sets. So there's medical signals we talked about, molecules, for example. There's a lot in drug discovery and that sort of stuff that's being used. And then you can have multimodal data sets too. And then beyond supervised learning, like you can have weakly supervised data sets, you can, or models, semi-supervised models, unsupervised models, and then image reconstruction is probably one of those that's being used a lot as well. And then some of the ethical challenges. I think we talked a little bit about ethics, but I think this is a very important aspect of using AI in medicine. There's unfortunately still a lot of uncertainty and distrust in AI predictions. Some of it actually is coming from actual data. So the way to go about this potentially is to develop some explainable algorithms and transparent model reporting, right? Like if you're working on a certain research project and you end up with some sort of a model, explain it enough for people to understand what exactly you've done. Regulation and governance of medical AI. I don't know if we talked about this specifically, but Health Canada is supposed to have something about AI in their regulations since 2014. I have not seen that guidance or guideline yet. And it was supposed to be released within a year. So I don't know what is happening exactly in the Health Canada level. Maybe they've done it and I haven't seen it. I don't know. But FDA has some of these, and even FDA like is pretty. They're pretty backlogged otherwise, so they're usually not that fast in responding to some of these. Shifts in responsibility. This is actually an interesting concept, and I think you probably either have been asked this or have thought about this. If a method or a model doesn't work well and gives you a wrong prediction, is the doctor to blame, the method, the company, the engineer who developed it? Who are we going to blame? I don't know. I don't know who you blame. Concerns about data privacy and security. So you build infrastructure for safe data sharing. For example, there's a lot of decentralized ways of data storage. There's federated learning that is being used a lot in different places. So you have some of these ways of trying to mitigate these risks. And then biased results that hurt marginalized groups. This is also an important aspect. You've probably heard about the usage of some of the AI algorithms in law enforcement and how it gets biased based on whatever data they're given before, because, well, surprise, surprise, humans are biased, and the data you're going to get from humans are going to be biased. So you feed that data into an algorithm, as neutral as it might be, it's still going to be biased. And so essentially, I think we're kind of going to expect more randomized controlled trials, kind of like this. This is a trial. I think I wrote the name of this somewhere here. Yeah, so Declare TIMI 58. This is a diabetes trial. They essentially looked at a certain drug against placebo, and they report certain outcomes. Expect more of these sorts of stuff. I've actually seen a few with AI algorithms. So you're going to see some comparisons of certain algorithms together, or an algorithm to an expert. So a lot of this is up and coming. And then expect usage of AI in actually planning and running RCTs. I actually found this neat paper that kind of talks about some of the future things AI can get into in terms of planning and running RCTs. So it can help get patients more accurately aligned with certain inclusion-exclusion criteria. So if you have certain inclusion criteria, it can help you with recruiting those sorts of patients. Can generate clinically important and relevant endpoints. So we talked about the study outcomes, for example. And again, I'm going to try and motor through this. And can also help with direct measurement of treatment effects by using data-driven approaches rather than just qualitative stuff. And it can also generate a virtual control arm where you don't have enough patients, but you can at least have a virtual or rather control participants. So you actually have this virtual control arm, especially in rare diseases and stuff that can be used. But again, proceed with caution, because, for example, I saw this paper where they talked about how this is actually an RCT where AI was worse than senior consultants in diagnosing childhood cataract from ocular images. But again, senior consultants, these are pediatric ophthalmologists who have been working for 5 years at least. So, and this is on top of their residency and fellowship and all that stuff. So like these are experts in that field. So you need to be careful what you're comparing this to and which situation and setting you're using this in, right? And then AI generated clinical outcomes that I just talked about here might not always be helpful. So you might get this computerized interpretation of cardiotocographs, which are the measurements of baby height rates. And this was generated by AI. It was not really helpful clinically. They looked at it and they're like, okay, this doesn't actually give us any sort of useful data. But again, this is one example. So I'm just trying to be balanced here of like, there is obviously challenges and opportunities on both sides, and you need to be careful. Okay, so that's the course, but I'm going to give you a note about the PD credits and elective credits and certificates and stuff. I'm hoping people online stayed to hear this because there were a bunch of questions when we first started. Okay, so for the course, if you're a pre-clerk medical student and you're using this course to get MD program elective credits, I will send you an assignment link to complete. It's a reflective assignment. I will do this hopefully tonight. I have 3 reminders. So unless somehow all my electronic devices go out of sync, this link is going to land in your inbox at some point. And then please do this by next Wednesday. And as soon as you submit it, go on to your assess.med. Those of you in med school know how to do this. And put the elective name in there and make sure you choose Hollis as your preceptor, Dr. Hollis Lai. And then essentially once you've done the assignment and done this, then he'll be able to essentially say and approve that you've done this. Email or DM me if you have any questions or if something goes wrong. If you're a grad student and you're claiming FGSR professional development credits, you know that you get these in 3-hour increments. And so you had to have come in for each one of those sections, essentially the 4 sections that we talked about initially in the course as well, to get these 3 hours. So you don't get 1 PD credits for just showing up to one lecture. I would really appreciate if I don't have to respond to some of those questions tonight, because I've been doing that for the whole 12 weeks or 13 weeks now, because we had a reading week. But anyway, so if you have come to one of those sections and you essentially get the 3-hour increments of PD credits, these should be reflected on Campus Bridge pretty soon. If you don't see them by April 19th, let me know. So we're gonna essentially tell FGSR that however hours you've done, and then it's up to them to put on Campus Bridge. So hopefully they will be pretty quick with this, but if you don't get this by April 19th, let us know. If you are getting a certificate from AIMS, and this is the AIMS-U Alberta, so the University of Alberta branch, not the university itself. I'm going to say this again. I think I said I don't want the U of A lawyers to come after me. So I will do this again. You're getting the certificate from AIMS if this is what you want. So you would have had to come in synchronously or asynchronously. And if this was asynchronous, you would have had to watch the recordings using the Zoom link I provided, not the website. And then again, you'll get an assignment link on Wednesday, April 12th. So next week, you'll have 1 week to submit this. So you will have until the week after, essentially 11:59 p.m. Wednesday, April 19th. And the form will close at that time. And then once you've done all of that, we'll send the certificates to everyone who's successfully passed the course, meaning they've come to the lectures and they've done the assignment in early May. If you have any questions or if you don't get this in early May, let us know. Okay, well, I know I'm over time, but I hope I've convinced you that AI is in the future of medicine and is the future of medicine. And that all of us are going to be affected by it, whether we're developers, patients, clinicians, working in healthcare, any sort of that stuff. There are lots of resources to know more about this. We also provide a lot of resources. Again, like I mentioned, if you're interested, let us know in the forum. And also come back and help us with the course next year. This will be great to have some of the feedback from this year. And you can essentially get involved as much as you'd like, as little as you like, or as much as you like. It could be just giving us feedback. It could be TAing with the course. It could be helping develop certain lectures. And with that, I'd like to say thank you. There's a bunch of people on this list. I think I named most of them at least, but obviously I'd like to thank Hollis Lai. He was the reason this course actually became an elective this year. Diana and Tariq helped us with the first lecture, Afia, second and third, Gulnaz, I'm not going to say what lecture they helped with. Amin Riza, Dr. Nidhi Hegde, Dr. David Wishart, Jean Hamad, Dr. Shane Eaton, Michael Shee, Bahar Beruzias, Dr. Amirai, CU, Brody Jackson, Fayaz Ahmed, Marcus Kim, and Delaney McIntosh. All of these people have had a hand in this. So thank you all. My email is there. I saw a question on Zoom about the email, so my email is there. And if you have any questions, you can email me or send me a DM on Slack. I'd like to say I'm pretty responsive on both. And then I also have some references and further reading on these slides. Again, I will share all of these with you. The ones that are bolded are the ones that I specifically had in the slides. And I'm going to just go through this just to tell you this actually took a bit of time. And yes, I went through all of these. I didn't just put them in there based on one sentence. Okay, that's the attendance tracker. If you have not done this, do it. I think the people over Zoom have the link, and I think everyone in person has done it. I'm going to wait for those of you who are doing this, do this. Okay, and then this is now the most important part. I'm sure you're here for this, not for the lecture. Okay, so please give us feedback. This is the link to give us all of that feedback. It's honestly, it's not going to take too long. And you're helping the future students that are taking the course to actually essentially have a good experience in here. You're going to have an option to opt in to win prizes, and we're going to have good prizes this time. I have somehow gotten a little bit of funding to do this. So please do this. Those of you online who have not left, and those of you in person, this is your pass to get pizza. I'm just joking. You get pizza anyways if you're in person. Okay, and that's it. If there are any questions, happy to answer them. Or if you want to come and talk to me, that's okay as well. But the pizza is up there. So I will get people to go grab pizza. Those of you online, you missed this. Too bad, so sad, sorry. But those of you in person, you can grab your pizzas. Thank you, everyone.